Welcome to SPSS. I'm going to show you how to do your homework in SPSS. First of all, you got this data on an Excel. It's two separate problems. You got the four valves as your first problem. The residuals is your second problem. So what you have to do is run a one-way ANOVA to compare the means between valve 1, valve 2, valve 3, valve 4, the means of this data, to see if any of the means are significantly far apart from each other, which is measured by standard deviations. Remember, if they're more than two standard deviations apart, you're going to say that there's a significant difference. But we're going to run the ANOVA. First thing, this data is not coded properly to run an ANOVA and SPSS. Very important, your IVs for an ANOVA always are categorical variables. So there is no categorical variable here, right? These are actually the DVs, right? They're numbered. What is physically measured is the DV. So these are all the DVs, but we're going to have to make a new group. That's where group 1 is valve 1, group 2 is valve 2, group 3 is valve 3, group 4 is valve 4, and we're going to set it up. So let me show you how that looks. Hold on. All right, so valve 1 is group 1. So how many are there? There's 10. So down here, I made 10 number ones. They're all identifying which group these guys are. Now I'm going to cut and paste these scores into this new column over here. Copy, pasty. Get in there, you. Okay, so how many are in group 2? 10. So I'm going to go down here and make 10 twos. I'm going to copy that in the sidebar here. But I'm going to make 10 twos, and I'm going to paste these guys back in here. Paste. Okay. So now this identifies who is in valve 2. Okay, so I just did the same thing for valve 3 and valve 4. Okay. So now the data is ready to be cut and pasted into SPSS. So what I'm going to do first is open up a fresh SPSS sheet. Hold on. Isn't it pretty? Make sure you're in the data view down here. This is where the real actual measured numbers are. So let's go back to our Excel. And where are you? You are right here. Okay, so just the numbers. Highlight them, cut and paste them. Copy. Switch over to your data set. Go to cell A1, right click, paste, give it a second, takes a while. Okay, so variable ones, we're going to go in and rename them. You're going to go to variable view. So this first variable is the grouping variable, and get used to calling them groups in ANOVAs, right? So this tells you, type means that you're dealing with a number. This tells you how many spaces you can have in your name, kind of not very important. Decimals. Since we're not using decimals with this one, I'm going to get rid of them. Label, it's just going to be the same as name if you leave blank values. This is what we have to do. So we have to label the individual subgroups of the group. The subgroups are also called levels. So 1 means valve 1. Now you could put spaces in here. The only places you cannot put spaces is in the name category, okay? 2 is going to be valve 2. 3 will be, what should we call that? Oh, yeah, that's a good one, valve 3. And the last one is 4, is going to be valve 4. So again, these are what we are calling our labels. And a label is the name for a level of a group. In other words, it's the name of a subgroup. Okay, add 1, 2, 3, 4, click OK. And missing, we don't care, just leave that blank. Columns, that's not important to us right now. A line, we don't care where it is. The measure, you got to tell what kind of variable is it. This one is a nominal. That means categorical. Okay, and since we're down here, the next one is the measurement of milliseconds, and they're measured in just regular numbers, continuous. That's called a scale. And let's name this one, I guess just what, milliseconds? Bam. So we named them. Check our data view. Yeah, we're good to go, right? So these are the valve 1 scores, valve 2 scores, et cetera, et cetera. So we have our categorical IV, we have our continuous DV, we're ready to go. First thing you're going to do before you run your ANOVA is you're going to check your assumptions. What are the assumptions of an ANOVA? The data has to be normal. In other words, the DV has to be normal. There's two ways you could have done this. You could have done them by individual, like valve 1, you could check for normality. Valve 2, you could check for normality, etc., etc. Or you could do like what we're about to do. We lumped them all together, valve 1, valve 2, valve 3, valve 4, and we just lumped them all together. We're going to check that one variable for normality. Okay. The second assumption is independence of observation. That's if somebody from valve 1 was messing around with what valve 3 was doing. In other words, independence of observation is if somebody from one group is interfering with somebody in another group, that violates that, and we just have to assume it with an ANOVA. And the last one is homogeneity of variance. So that means the spread of the data has to be relatively the same between valve 1, valve 2, valve 3, etc., etc. Go to Analyze. 99.9% of everything you do in SPSS is going to be under Analyze. Got it? So Analyze. We're going to do the descriptive statistics. There are many ways to test for normality. The one I prefer is Explore. I'll show you why. So you're only looking for the DV, whatever's measured with numbers for normality. So we're going to click that into the dependence list, and we're going to get the descriptives. That's the mean and the standard deviation, that kind of stuff. Plots. We really don't use the stem and leaf, but we do use the histogram, and this is your money box. Normality plots. It will run a math test called the Kolmogorov-Smirnov test that will tell you if your data is in fact normal or not. So that's the one you're going to go by. Click continue, no options, click OK. It's going to put the output here for you. So this is now an SPV file. The P stands for output. The one with the numbers on it, this is an SAV file. So SPSS has two files. The ones with the numbers on it, the data, is an SAV file. The one with the graphics and all the charts and tables and everything, that's an SPV file. All right, let's look at the data. There's 40 pieces of data. There's the mean for everybody, standard deviation, confidence interval, etc., etc. Here's the first money box, test of normality. This means that the overall data was, in fact, violated the assumption of normality. Okay? If you did them individually, again, if you did valve 1, valve 2, valve 3, valve 4, you would have got that each one of those was considered normal. So, but with the ANOVA, we simply say it's a very robust analysis, and we keep pressing on. In fact, robust means it's hard to screw up. So you can get away with violating either the normality or the homogeneity variance, but not more than one. Okay, so normality is violated. There's our histogram. It doesn't look very normal to me either, right? It's got this giant spike here, which means it tends to be kurtotic. Kurtotic means you got too many spikes, or there's one or two or three that are way too high or too low. Skewed means that it's slanted to the left or to the right, but this looks like it's kurtotic, which is violating the assumption of normality. And there's the stem and leaf plot, which we don't want. And this is a normal plot. The data should fit. These little dots should fit right on this line, just like a snake. And you can see it's a little bit up and down. So, again, we violated the assumption of normality. All right, here's the subgroup stores, right? Valve 1, valve 2, these are all the milliseconds. I'm going to do a different normality check just on the individuals to see if that comes out different than the overall. And I'm pretty sure it does. So I'm going to go to Descriptives, Explore. And I'm going to just put these guys in one at a time. And I'm going to check each individual subgroup to see if they are normal or not. Okay, so continue, click OK. So let's go back to the output sheet. Where are you? Output sheet. All right, so here's the 4. There's the mean of valve 1, 14.6. The mean of valve 2, 16. The mean of valve 3 is 25. Oh, yeah, you're going to have a significant difference in there somewhere. Mean of valve 4. So here's the Smirnov test right there. Okay, so I'm going to use this one instead because according to this, none of the individual subgroups violated the assumption of normality. So, see, we just kind of fudged it a little bit. Not really, but, you could say that the data did not violate the assumptions of normality if you break them down individual. So that's what we're going to do. Very important, if these SIG values, SIG values, if these values are less than 0.05, you violated the assumption. I'll say that again. If the SIG values are less than 0.05, you have violated that assumption. So a SIG value is the same as a p-value. Those calculated p-values that you guys have been doing, those means the exact same things as SIG value in SPSS. So now let's go back to the data sheet. Actually, you don't have to do the data sheet. We can do it here. So to check the homogeneity variance, you have to run the physical test. So to run an ANOVA, analyze, general linear model. Univariate means you have 1 dV. ANOVAs can only have 1 dV. Okay. This data set you can't use in this format. That's why we have to put it. That's why we put it in that other format. Give me 1 second and I'll pull the other one up. Ready, Freddy? Okay, so again, analyze, general linear model, univariate, 1 dV. Our dV is our milliseconds. Remember, that's what's physically measured in everybody. And this is our group. That's your factor. Factor from now on means categorical variable for you. And then you check these boxes. Nah, that's too advanced. Contrast, not worried about it. Plot, no. Post hoc. You need more than 3 groups to run a post hoc, and you do. You got 4 groups. Okay. So what you do is you put the group, the variable name group, click it over to the post hoc. We normally do a Tukey test. Tukey test will split down all 4 of the groups. It'll compare group 1 mean to group 2 mean, group 1 mean to group 3, group 1 to group 4, etc., etc. It'll make all possible pairwise combinations and tell you which ones are significantly different or not. And the rest of these, we want options. Muy importante, under options, you just click overall. It's going to do everybody. But you always want the means and the standard deviations, effect size, power, power, power. And there's your homogeneity variance test right there. So you click that, continue. You are ready to go. You click this OK button. Cross your fingers. Let's see what it looks like on the output. All right, here's the output. Let's scroll down a little bit. So there's your ANOVA, right? That's the title of it. This first box tells you how many were in each group, right? 10 in each group. There's your means and standard deviations. This is a very important box when you write up the results because you have to put the mean and the standard deviation with only 2 place values. That's APA formatting. And here is your homogeneity variance test. This is called the Levines test. Again, since this SIG value is not less than 0.05, then you did not violate. So you did not violate the assumption of homogeneity variance. This one is your money box. This is your actual ANOVA. Okay? So the corrected model and the group should be the same numbers because you only got 1 IV here, so they should be the same numbers. But this is your F test ratio, 30.158. What that means is that you can explain 30 times the variance from between the groups as you can within the groups. So in other words, it's the difference of the group that's making the difference. So in other words, you got a giant F. Usually an F, anything over 3 or 4 is going to be significant. And again, this SIG value is less than 0.05. Therefore, you get to reject the null. Remember, the null states that there's no significant difference between this means, but you get to reject that now. That's what this means. So you get to say, yes, there is a significant difference between those means. And sidebar, partial eta squared is the same as effect size. What this means is 0.715, you can explain about 71% of the variance. You can explain roughly 70% of the variance. It's really good. It's really strong. That means the difference between these milliseconds is coming because they're from different valves. Okay. And marginal means don't need to know that. But here's your Tukey test. So group valve 1 compared to valve 2, there's the difference. That's the significance. In other words, there was no significant difference between valve 1 and valve 2. Next line, valve 1 to valve 3. There was a significant difference between valve 1 and valve 3. Between valve 1 and valve 4, no significant difference. So what you do is you look down this significance row. Anything that's less than 0.05, you're going to get significance. So there's 1. So that's between 2 and 3. And then valve 3, look at valve 3, they're significant all the way across. So basically, you go up to the means again, and it looks like either valve 3 is either the smallest or the largest. And you could tell right off the bat that valve 3 is the slowest, valve 1 is the quickest. So if I had to recommend one, it's going to be valve 1. But that's it for the first homework. Hold on. I'm just going to check the homework sheet, make sure I got over everything. So basically, when you turn your homework in, she's going to want to see the boxes and tables and charts and graphs that prove the assumptions were not violated. So again, the normality test, we always look at the Kolmogorov-Smirnov test. If your sample size is really small, you use the Shapiro-Wilk, but we got a pretty good sample size there. And there's all the histograms. Remember, I switched the normality check to each individual valve. And that sure doesn't look normal to me, but it did not violate the assumptions according to the Levines test. Oh, no, according to the Kolmogorov-Smirnov test, none of these violated the assumptions, right? These SIGs had to be less than 0.05. This one's kind of close, but you just let the believe what the data says. That doesn't look normal to me. There's valve 2. That's kind of normal. Valve 3, again, it's kind of normal. And again, 4 is kind of normal. Okay, so there's your how many are in each group. Homogeneity variance, not violated. There's your ANOVA box, your between subjects box with your F scores and effect size. This is how you write it up in APA formatting, okay? I'm going to leave that up there for a second. But you got to write it up like this, right? The F means you ran an ANOVA. The 3 tells you it's your between group degrees of freedom. 36 is your within group degrees of freedom. Watch the videos on how to calculate these, and the rest you just take from the table. All right, and then the second one, I'm not going to make the video. It's the exact same process. So that's it. Hope it helps. MGZ, out.